GPT for pass the bar exam. Claude writes better than most graduates. Gemini can look at a photo and describe what's in it. None of these systems were explicitly programmed to do any of those things. They learned by reading text. That's the magic trick behind every large language model. And in 5 minutes, you'll understand exactly how it works. So, what's an LLM? A large language model is a neural network trained to predict the next word in a sequence, billions of times, across hundreds of billions of words of text. Through that process, it develops an internal model of language, of facts, of logic, of cause and effect. It's not a database. It doesn't look things up. It generates text by predicting what comes next, based on everything it learned during training. Here's how training works at a high level. You take an enormous corpus of text, books, websites, code, research papers. You show the model a sentence with the last word hidden and ask it to predict what goes there. It guesses wrong. You correct it. You do this trillions of times, adjusting the model's billions of parameters each time it gets something wrong. Eventually, the model gets very good at predicting text. And in the process of learning to predict text, it learns an enormous amount about the world. Why does predicting text make a model that can write code and reason? Because language is a compression of human thought. To predict what word comes after, the patient recovered after, you need to understand medicine, cause and effect, grammar, and context. To predict what comes after, the function returns, you need to understand programming logic. The model doesn't learn these things separately. It learns them all at once, encoded in the patterns of language. Scale matters enormously. A model with 100 billion parameters sees patterns a smaller model misses entirely. But LLMs have real, important limitations. First, they hallucinate. They generate confident-sounding text that's factually wrong because they're predicting plausible text, not looking up verified facts. Second, they've a knowledge cutoff. They don't know about events after their training date. Third, they don't have memory by default. Each conversation starts fresh. Fourth, they can be inconsistent. Ask the same question twice and get different answers. Understanding these limits is as important as understanding the capabilities. How's an LLM different from a search engine or a database? A search engine retrieves existing documents. It finds, not creates. A database stores and queries structured facts. It looks up, not reasons. An LLM generates new text by reasoning over learned patterns. It creates, not retrieves. This is why LLMs are powerful for writing, summarizing, and reasoning, and why they're unreliable as a source of verified facts. The best AI systems combine all three: an LLM for reasoning, retrieval for facts, and a database for structured data. What makes one LLM better than another? 3 things: scale, training data, and alignment. Scale, the number of parameters, determines raw capability. More parameters means the model can hold more complex patterns. Training data determines what the model knows and how it reasons. A model trained on high-quality, diverse data performs better than one trained on more but noisier data. Alignment, specifically RLHF, reinforcement learning from human feedback, is what makes the model helpful, honest, and safe instead of just statistically plausible. Here's the one thing to remember. An LLM isn't a database. It doesn't look things up. It predicts what text should come next, based on patterns learned from an enormous amount of human writing. That's why it can write, reason, and code. It's also why it can be wrong with confidence. It's a prediction engine, not a fact machine. Use it for reasoning, writing, and synthesis. For facts, give it access to your data. That's what RAG is for. That's large language models explained in 5 minutes. Subscribe to AI SkillSprint for one AI concept explained simply every week. Next up, what's RAG and how do you give an LLM access to your own data? Drop your questions in the comments below.